Hello, everyone. Welcome, people that are here in person and online. So I'm going to be talking about the Arduino VENTUNO Q. Now, I'm assuming most people here have heard of Arduino, but I'm going to give a little bit of background for those that don't. I also have my co-presenter, Jim Bruges, he's a senior engineer from Edge Impulse, which was recently acquired by Qualcomm. Last year, Qualcomm acquired Arduino, but Arduino is still very much its own entity. We want to preserve everything about Arduino that made Arduino great, its openness, its developer ecosystem. What I'm going to do is I'm going to start by going through Arduino and the evolution of edge computing, showing some of the most recent products. I'm going to talk about the Arduino VENTUNO Q board, which is a new board that we're launching this summer, which is a big upgrade to the Uno Q, which was launched late last year. I'm going to talk about our Arduino and Canonical collaboration, how we are working together between Qualcomm, Canonical, and Arduino to bring a great experience to the VENTUNO Q. Then I'm going to go through the development experience in Arduino App Lab, and then Jim is going to finish it off by talking about AI on the edge. The theme of this presentation is how you can bring your great ideas from prototype to production. What is Arduino? Now, I'm assuming most people have heard about you, but at a high level, it's an open ecosystem designed to reduce the friction between an idea and a working system. It does this through hardware abstraction. It's got open specs, open tooling, a broad ecosystem of boards and shields that are backwards compatible with previous Arduino generations. There's a massive developer ecosystem, millions of libraries, drivers, examples, community knowledge. It's from the MCU to Linux to Edge AI. And I'm going to talk about how the VENTUNO Q brings the Qualcomm processor side to the MCU side and how it's all connected together with App Lab. It's designed for prototyping to production. How can you take your great ideas and actually commercialize them and turn them into real-world products? Arduino lowers the barrier to working with hardware so developers can focus on software, systems, and outcomes, not focusing on board bring up. On the right side, you hear this is just a very small sample of the many different Arduino products. There's an R3 on there, an R4, there's the Nano series, the MKR, there's different shields and accessors, LED matrix, there's all kinds of things you can plug in together. I don't have a PowerPoint slide or a slide big enough to put all of these boards on there. Now, an AI evolution at the edge. So starting on the left, I've got the Uno R3, which was launched a little bit ago. This is an 8-bit microprocessor. For those that are familiar with Arduino, it runs sketches, which you can think of as like a C++ program that runs in a loop that can control basic things like sensors. It can turn them on and off, basic motors. The Uno R4 upgrades this 8-bit MCU to a 32-bit. And then from the R4, we have the Uno Q, and this is where we introduce what we call a dual brain architecture. You've got a Qualcomm 4-core processor that's running a Debian-based OS, so it's using apt packages, you can do your apt update, but it's also running a 32-bit MCU for that real-time deterministic control. And then this summer, we're very excited to launch the VENTUNO Q. And this is a significant upgrade from a 4-core processor to an 8-core. We're adding an NPU to it with 40 TOPS of performance, where you can take those AI workloads, those image classification, object detection, all the different things that can run in 40 TOPS of performance, and bring that to the MCU side for real-time control. So I just thought it'd be kind of fun to do a little comparison between the Uno Q and the VENTUNO Q. So on the top, you have the CPU. This is a 4-core Cryo running at 2 gigahertz. With the VENTUNO Q, it's a big upgrade to an iQ8275 running at 8-core. This is the exact same processor on the Qualcomm IQ8 series, which means that when you develop something on the VENTUNO Q, you can commercialize it with the IQ8 with about the same performance. So you can prototype those AI workloads, see how they perform, and then get that industrial temperature, minus 40 degrees, 125 degrees with an IQ8. On the MCU side, it's got an STM32U585 for the Uno Q, running at, I believe, 160 megahertz, roughly. But that gets upgraded to the H5F5 running at 250 megahertz. It's slightly more than a 50% jump in performance on your real-time control. That's running the Zephyr OS for the RTOS. The GPU goes from a Qualcomm Arduino 702 to the Arduino 623. Now, don't be confused by the 7 to the 6 series. The 623 is actually a much more capable GPU. On the ISP, it's got dual ISP, so you can connect 2 MIPI CSI cameras on the Uno Q. We increased that to 3. That's 3 concurrent video streams that you can run on the VENTUNO. On the display, you can actually use this as a single board computer on both of these. You have a DSI display interface for the Uno Q, but the VENTUNO Q gives you not just the DSI interface, it also has an HDMI connector, and you can use DisplayPort over USB Type-C. You can run up to 2 concurrent displays at a time on a VENTUNO Q. And for those that are in the audience, we actually have a demo of that running in the next room that we'll be showing later. As for the memory, it's 2 or 4 gigs of LPDDR4. That gets upgraded to 16 gigs of LPDDR5. You can get 16 or 32 gigs of storage with the Uno Q. That goes to 64 gigabytes with the VENTUNO Q. As far as connectivity goes, it's a generational upgrade from Wi-Fi 5 to Wi-Fi 6, Bluetooth 5.1 to 5.3. It includes USB Type-C on both. They both have a quick I2C connector, but the VENTUNO Q also adds a 2.5 gigabit Ethernet port, and it adds 2 USB Type-A ports, so it makes it easier to connect your keyboard and mouse. The really exciting thing, though, is the VENTUNO Q is introducing a Qualcomm Hexagon NPU, neural processing unit, with 40 TOPS of AI performance. This is great for LLMs, VLMs, vision, voice. You can run those AI workloads on the application processor side and then control like a robot on the MCU side with real-time deterministic control. The expansion, it's roughly the same. You get the classic Uno headers, the camera, the display audio, the shields, the carriers, the quick modulinos, but the VENTUNO Q also adds a 40-pin high-speed GPIO expansion. The OS is being upgraded from Debian to now we're giving you the full Ubuntu experience on the VENTUNO Q. That's why we're here to talk about that. Both have Zephyr running on the MCU, and every board comes with Arduino App Lab pre-installed. Dual brain architecture. That's what we call this. Now, in this picture, you see 2 boards. You don't need 2 boards to do this. I just want to show the top and the bottom of the board. It's got the IQ8275 running 40 TOPS of performance. You can develop your processor with AppLab running Python, taking the output from the AI models, and then use that through a remote procedure call to control the MCU that's running on the board. It comes pre-installed with AppLab. For those that are familiar with sketches, it will write the sketches to the MCU. This is a kind of an infinite loop to control the microcontroller. Comes with Ubuntu OS, and everything's running on Zephyr OS for the MCU. And I'll get into the AppLab experience a little bit more later. But what I really want to do is spend a little bit of time talking about the collaboration, because this is important. It's going to come preloaded with Ubuntu, which means you're going to get ongoing security updates. It comes with the 30,000, probably more, a lot more than 30,000 supported packages that can run out of the box. It's the same software from prototype to production. That's the important thing I want everyone to remember. You can start with the VENTUNO Q, get your app lab, get your app working, whatever use case that you want to do, and then you can commercialize it. It's an embedded developer to the app developer, and best of all, just like other Arduino products, there's an open source SOM. You can take the schematic, you can build your own hardware off of it. Maybe you don't need that many CSI camera ports. You can take this and then develop. For the users, we're including Ubuntu Pro as part of the VENTUNO Q experience. And it gives you 10 years of coverage per device. It's automatic. You don't have to put in your email address. You don't have to register. It's going to be a key, that's a unique key is going to be preloaded on every board so that it just works out of the box. And if you really need it, that means you could do fleet management, including landscape. Where this is important is we're planning to do quarterly platform updates with the new version of the OS, but you can always do an apt update in between. That's still supported. And then for those that are maybe heard of the Cyber Resiliency Act, this is a requirement that If you put an embedded device and you commercialize it, you have to keep it updated for the life of the product. With Ubuntu Pro, you're going to get those 10 years of updates and coverage included. What's next? So we're launching with 24.04 this summer, but we're working on 26.04 right now. That means that with the LTS, the 10 years of support, this board is going to get updates till 2036. Ubuntu Core is what we're looking for the next iteration of how we want to expand this. For if you want a more smaller container-based secure OS, Ubuntu Core will give you that. Our collaboration is growing. So I have a QR code on the side. I'll leave it up there for a few seconds for anybody that wants to scan it. That's going to take you to the ubuntu.com page, which shows all the different Qualcomm products. It's a single IoT image that you install between the VENTUNO Q, the IQ8, the IQ9, and there's going to be more Qualcomm SoCs are being added in the future. So this collaboration is growing. This is a picture of where that QR code takes you. I've got the IQ9 selected. The IQ8275 that you see right here, this is what the VENTUNO Q is based off of. One system image runs on all of these boards, the IQX, the Rubik's Pi, the RB3, more are being added. It's the same image that also runs on the VENTUNO Q. The only difference is we're preloading it with AppLab and like the ADB service so that you can connect to it. And we're installing a couple of Ubuntu packages like Docker so that the containers just work right out of the box. Now, let me introduce you to AppLab. So this is a unified development experience for the VENTUNO Q. The key idea is that the traditional barrier between the embedded developer and Linux AI development is bringing everything into a single workflow that's easier to use. From AppLab, we got a lot of pre-built bricks, which I'll get into in a little bit, that you can just download those. You pick it from a GUI, and the code's there. You can combine bricks together. This could be doing something like, let's say you're doing a video stream from your cameras, and you want to do object detection or image classification from it. These are pre-built. We have a whole team at Qualcomm that's taking all the most popular AI models. They're optimizing them to run on the VENTUNO Q, and then bringing it into the AppLab experience so that it works just right outside of the box. And there's a lot of sample code that you can run as well if you want to blink an LED or something. And then you can use that as your starting base. You don't have to focus on the complex hardware setup that most embedded developers have to do. AppLab is the orchestration layer across these domains so that a single application can run across the CPU, the GPU, the NPU, and then through the remote procedure call to the MCU. Now, one of the cool things with both the UNO Q and the VENTUNO Q is they can operate in two different modes. We call it standalone mode, or we refer to it as SBC mode, which is standalone board computer, or it can run in PC connected mode. In the standalone mode, you can connect to the DSi display, you can connect a keyboard, a mouse, and you can use it as a standalone computer. Once you flash the OS to it, it can run on its own. Or for people that are more familiar with the existing Arduino experience, you can use it in PC connected mode. And in this case, you just connect a single USB Type-C computer to it. AppLab runs on your laptop, and it will push the containers to the system and run it for you. You don't have to connect a monitor. You don't have to connect a keyboard or mouse. It just works out of the box. Even when I set it up, I literally plugged the cable into it. I flashed the OS, and AppLab just recognized it right away. I clicked on it. It showed me all these different bricks and containers and AI workloads that I could run. Very seamless experience. We're trying to make it very easy for the developer. So you don't have to focus on the hardware or any complex OS setup. It just want it to work out of the box. Now, it's going to come with curated examples. This is a screenshot of some of the different bricks and stuff that you can pick and choose from. Bricks are kind of like containers, and you can combine different bricks together. And this is what we're doing to make the experience easier. Python code is what you can write for those that are familiar with Python on Linux. So it's doing something on the AI side. Let's just say you're doing object detection, detects a cat, and now I want to run some Python code on the MCU to do something. One thing that I personally want to develop this summer, if I have some time, is I'm from Oregon, and in my backyard, I don't know how they get there, but we have possums that show up in our yard. And for those that don't know what a possum is, it kind of looks like a really fat cat. They're very poofy, big poofy tails. They're mostly harmless, but they like to dig through my trash, and they like to knock it over. Even worse, my wife likes to do gardening back there, and she's got this, I don't know what you call it, it's like a liquid fish fertilizer, and they chew the top of it off and they try to drink it. It can't be healthy for them. And then we let our dogs back out there, they smell the fertilizer, and then they try to drink it. So it just becomes a problem during the summer. I have no idea how they get there. My house it's 16 feet in the air and it's fenced off. That's about 5 meters, but somehow they get up there every summer. So my idea was I could use the Ventuno Q, put a camera on it through the ISP. You take one of the bricks that can do real-time object detection and classification, detect, is it a possum? Is it a dog? Hook it up to a water gun with a servo motor, the bucket of water, and then have the camera move it around and point. And then once that it sees a possum, just give it a gentle squirt to shoo shit out of the way. But I don't want to squirt my dogs because I don't want the dogs to be scared of going out back there. Except in the case that the dog gets to the fertilizer, then I want to give them a little squirt to say, get away, get away. Now, that's just my idea. If somebody wants to take it, I'm okay with that. If you do commercialize it, please give me one. I could really use something like this. So, but that's just some of the mini examples that you can do. You grab those bricks, you change the code. I say, Python, is it a possum? Yes. Pull the servo motor, squirt them. And then maybe control it so that it's center frame on the camera. I could see someone building this into a water gun with a nice camera, and they've got these really cool water guns I've been wanting to get that automatically shoot. Seems like I could use one of those. So now I'm going to turn it over to Jim. He's going to talk to you about the prototype to production and actually deploying AI at the edge.
So I'm going to talk a little bit about the AI story with the Ventuno Q. I'm from Edge Impulse. We're another company that Qualcomm acquired into the kind of IoT business unit last year. And the first thing I want you to all think about is, what does the real world really look like to a human? You know, I can see that you're all people standing in front of me. I can smell that maybe there was some coffee going on earlier. I can touch this lectern and sort of feel that it's painted. All of these things are senses that we have as humans, but we're not getting the raw data into our brain. We're getting the raw data and performing an inference on that data to get an insight. We're turning that raw data from kind of just a signal into something useful. And that's really what Arduino's been all about ever since it started. It's about that bridge between the kind of software world where you can create rules and the hardware world, the real world. And basically, what the Ventuno Q is able to do is really take that a step further by using AI directly on the device to give you that extra insight based on whatever sensor data that you might be kind of using down at the edge. So some of the example sort of AI applications that we're envisioning people building with the Ventuno Q include, of course, kind of vision-guided robotics, all the rage, also offline voice assistants, local LLMs. I've been talking to a bunch of people in the crowd today about some of the work that's going on shrinking down these cloud models to fit onto edge devices. And the sorts of things that you can run on the Ventuno Q now, think Gemma 4, think Quen, they're all now really, really easily accessible down at this level of low-cost, high-performance hardware. But then more on the industrial inspection side of things, my bread and butter has been building industrial inspection systems with customers with Edge Impulse for doing things like defect detection on production lines. And then predictive maintenance, sort of using that sensor data in a factory to go, you know, rather than Greg going down to the factory floor on a Friday, putting his hand on one of the big pieces of rotating machinery and saying, yeah, the bearing's failing, we need to do some maintenance on this machine. We can use sensors, you know, time series based sensor AI to do that predictive maintenance automatically with these sorts of devices. And then smart environments. I think the future of kind of the smart home is going to be pulling together sensor sources from all these different places and using a central hub like the Uno Q or the Ventuno Q to run multimodal AI systems that can really take action based on what they're seeing without you necessarily needing to train something from scratch. So those are some of the example AI applications that we're envisioning for the Ventuno. But how are we helping you develop tools with generative AI, with audio intelligence, with vision AI, and with robotics? The first of them is through AppLab. So Arduino is bringing this really simple method of pulling together pre-existing bricks, pre-existing bits of application that people have built in the community, the same way that they've done for the microcontroller for years with Arduino libraries, on the Linux side with Python. But then there are two other tools that Qualcomm has that can help Arduino bring even more of this richness of AI to devices like the Uno Q and the Ventuno Q. And the first of them is Edge Impulse, who I work for. So I don't know if you're familiar with Edge Impulse, but we're a software platform and a set of engineering tools that give you a kind of end-to-end workflow for building discrete AI models for the edge. We're not talking with Edge Impulse about building LLMs or SLMs. We're talking about really small, refined AI models that solve a single problem based on sensor data. That might be detecting humans in an image. It might be detecting faulty machinery from vibration, but those sorts of discrete use cases. And to build those sorts of things, you need three things. You need a really high quality data set. So we have tools for helping you build data sets using any kind of sensor. You then need a really efficient model architecture. So we have a set of tools to help you build your model architecture and train a model that you know is going to run on that end device. And we give you tools to help you kind of benchmark as you're building your model to understand whether it will run on your edge device. And then the final thing is you need some way to deploy it. So we can compile down these models to run in really optimized C++, even on a microcontroller, or edge optimized executables for Linux and things that will allow you to take advantage of things like neural processing units, GPUs, even CPUs, and take advantage of the like instruction sets that are available on these edge devices to their best of the ability of the AI model. And where that becomes really easy is when you start to use Arduino hardware with it, because from Edge Impulse, you can one-click build and deploy to Arduino App Lab. Really, really simple. So once you've started building your models in the platform, it's really just a case of plugging in your Arduino Uno Q or Ventuno Q, clicking the button, and getting your model down onto device. Because the thing that I've found most difficult with customers over the years with Edge Impulse is that step from kind of 0 to 1. How do you get really quickly from I've got an idea of chasing my possum around with a water gun to really chasing the possum around with a water gun, even if it's sort of version 1 of it. So that's really the kind of pathway that we've been trying to solve. But Edge Impulse also provides that full toolkit to go all the way to production, as Eric was saying. Then the other tool that we have in our roster here is Qualcomm AI Hub. Now, this is on the other end of the spectrum. So while Edge Impulse helps you train models from scratch for these kind of discrete sensor perception use cases, AI Hub provides you with a bunch of pre-built models for all sorts of different modalities. So whether that's doing things like pose detection on humans or local LLMs or detecting cars in an image. These are sort of pre-built model blocks that you can take and you know will run really well on Qualcomm hardware. And the other thing that AI Hub provides is a way to run these workloads in the cloud on real hardware. So they have a server full of Qualcomm hardware that you can go and test out these workloads to see how they'll run before you get down to device. So you get both things there, a bunch of example models and applications, the pre-built models that you can go and build into your application, and then the way to test and optimize those models in the cloud. So that's a little overview of some of the ways that we're bringing AI to the edge with the Ventuno Q and Qualcomm. We've got a few minutes for questions now, so I'll bring Eric back up. But if you scan this QR code, you can get access to a bunch more information about the Ventuno Q, and you can register for interest. We'll be launching later this summer, and I'm really excited to see what everyone in the open source community builds. Thanks very much.